science. One real quick one would be just how cold do you expect it to be there on landing day? And secondly, a more substantive topic here on the microscopic capabilities of the spacecraft. Do you have any ability, Peter, to use your microscopic capabilities early before you start digging to maybe look at dust that's come out of the atmosphere or settled on landing leg or something?
Well, actually, our microscope is fixed on the deck, and it has a little sample wheel that pushes out to collect samples. And we're landing with that sample wheel exposed. So if the thrusters throw up a cloud of dust and it settles on the spacecraft, which it's very likely to do, some of it will settle right on that sample wheel, and we'll retract it first thing and actually look at the dust kicked up by the thrusters and that might have blown in from the atmosphere. So that's a very good question and something we plan to do for sure. The other question is the temperature. And the average temperature is about -50 at this location, and we expect that it could go as cold as the ice below the surface, which is -80, 90 centigrade, and maybe as warm as -20 centigrade. And of course, at midday will be the warmest, a little after midday will be the warmest temperatures. And when we first land, actually we land a little before the summer solstice. And so the sun is still rising every day at noon. It's a little bit higher, and then it sets very slowly. And even at midnight, the sun will be above the horizon, probably throughout the summer. I think it's somewhere in August that we actually see the midnight sun dip below the horizon for the first time. So we're going to have plenty of sunlight. We're not going to be looking at stars. And I think the temperatures will be as benign as they can be for the first 3 months of the mission.
Okay, I understand you have 2 more questions.
Two more questioners. This is Todd Halverson of Florida Today with a couple. First of all, I wonder if you can just tell us what your latest estimates are for the exact landing time, and then the exact time that you would receive an initial post-landing signal back on Earth.
Okay, I'll address that. There is some minor dispersions, actually some reasonable dispersions around what the exact landing time is, but nominally it will be at 4:53 Pacific time, and I should say that's Earth receive time, so the actual event is approximately 15 minutes earlier than that. But the time we touch down has some dispersion based on how the system operates. If we spend more time on the parachute and other things, delay it a little bit more. Now, your second question was how long before we receive signal. If everything works down the middle, down the way we planned it, we should have signal at touchdown. And as I mentioned before, we actually are communicating with Odyssey and MRO, real-time receiving the data back from Odyssey all the way through 1 minute after touchdown. And at that point, we turn off the radio and we won't hear from it again for another hour and a half.
Okay, thanks. And for Peter Smith, I'm wondering if you can talk about what you can and cannot do with your suite of instruments. In other words, I believe that you cannot directly detect microbial life, for instance.
No, we have not designed the instruments as life detection instruments. We are looking at the minerals, and we have little ovens that heat the soil samples. And as we get to temperatures where, say, a carbonate would decompose, we'll see a little puff of carbon dioxide come out. And by analyzing the gases that come out and the temperatures at which we see transitions, we'll be able to characterize clays, carbonates, sulfates, and other type of materials that are formed through the action of liquid water onto volcanic soils. And so we're looking for the changes caused by liquid water. We also do an experiment where we say, what would the soil be like if the ice melted? And because we don't want to wait 50,000 years for that event, we actually bring a little water with us, wet the soil, and we look at the chemistry of the wet soil. And this tells us about the kind of environment that would be available with the melted ice and wet soils. And then, of course, our microscope looks at the shapes of the grains and the clumping of the grains and the magnetic properties of the grains. but not so much with the idea of seeing microbes, but with the idea of looking at grain shapes. So we're really doing a full geologic and chemistry experiment on the surface with the idea of finding if this is a habitable zone. In other words, could the organic materials be there, the potential of liquid water when the warmer climate exists, and perhaps chemical energy sources that some microbes on the Earth use.
Peter, we're also going to sample ice, aren't we?
Excuse me. Ray points out we're sampling ice also. And we have special tools to do so. And we'll look at the properties of the ice, and we can compare the properties of the ice frozen into the surface with the water vapor that's in the atmosphere to see if there's a communication there, if there's an exchange between the atmosphere and the subsurface ice.
I believe we're going to go to Bill at Kennedy.
Yeah, hi. Thanks, guys. It's Bill Harwood with CBS News. And first of all, Ed, it's a pleasure to see you back on this panel. Your insights are always very welcome. I have three quick questions for Barry, if I could. What exactly do you know health-wise at the end of 60 seconds about the spacecraft? And also, could you give us a little more detail about what is ultimately life-limiting? I mean, obviously the temperature is going to do something, but 3 months is, I guess, the advertised lifetime. What do you think you could actually get if you're lucky? And I have a follow-up. Okay.
First question was, what would we get engineering-wise in the first 60 seconds after touchdown? One of the things we focus on is telemetering back to Odyssey and MRO, the information relative to EDL, so we'll have all the rates and all the time of parachute deploy, number of thrust counts, and what have you. Relative to the state of landing, we'll have information such as we do what we call a gyro compassing event, which determines what the lander tilt is relative to the surface, and various some health check information. So we have a fairly, if everything again goes nominally with EDL communication, in that first 60 seconds we get a wealth of information on spacecraft health, temperatures, and the like. I'm sorry, your second question was the lifetime. Yes. Life-limiting issues. The critical thing for us is energy. On Mars Exploration Rover, obviously, we've outlived the design lifetime, and we've had the luxury of being in the equatorial region. Living in Hawaii would be wonderful, but we live north of the Arctic Circle, and eventually the sun will go down, and will go down forever. I believe it's in January or so, January or February of next year, the sun will actually dip down below the horizon and won't rise for another 3 to 4 months. So we'll go 3 or 4 months without any solar energy at that point, and it's extraordinarily unlikely that the vehicle could survive that. Anywhere between 90 sols and the start and the time that we lose the sun on the surface of Mars relative to where Phoenix is landing, it's likely that we will go to what we call a power negative state, where we're consuming more energy than the solar rays are producing because the sun is now down a varying amount of time during this. As Peter mentioned, it's up 24.6 hours a sol, but it then starts decaying rather rapidly after that. So sometime between that